So in this lecture, what we'll do is we'll start with the similarity, or we'll start with a question. Okay. The question will be somewhat like, what is the electric field due to a charge carrying plate? Okay. And then what I'll try to do is I'll try to explain the similarities between Gauss law and Coulomb's law. Okay. How they are exactly the same. Understood? And then we'll follow up with few more questions from Herodot. Question number 3.22, 3.23, and 3.24. Understood? So this example is a very proper way of understanding the relation between Gauss law and Coulomb's law. Understood? Now in this question, what I'll try to do is I'll try to figure out the electric field at this point due to a current carrying, not current carrying, the charge carrying plate. Okay, this is charge carrying plate of surface charge density given as sigma. Okay, the surface charge density of this plate is given as sigma, and to find out the electric field at this point. Now, one thing you must note out here is to make it easier, I have located this point, okay, symmetrically. That means if you project this point, okay, at the center of the paper, or if you project this point, the plane of the paper, okay, this point will be symmetric to the plate. And why have I done that? So there is no y component or z component of electric field. Okay, if this point was asymmetric, will there be any electric field in z component, y component? Yes. Okay, the method of finding those are very similar to the method I'm doing out here. So to avoid complex calculation right now, what I'm doing is I'm trying to find out the electric field at this point. Okay, at this point, and this point is symmetric to the plane of paper. Understood? And this plane of paper carries a surface charge density sigma. If I look at this paper, can I say this paper is nothing but an integration of line from top to bottom? If I integrate lines, okay, from top to bottom, I'll make up this paper. So I do the same thing in this calculation. I take an element of thickness dx. Okay, situated out here, and this dx element is x above this point. Fair and fine. And what was the electric field due to a line carrying charge? Ex is equals to k lambda by r into sine theta from phi a to minus phi b, and Ey, or y component of electric field, is equals to k lambda by r into cos theta from phi a to minus phi b. Okay, these I've already derived in previous lectures. Fair and fine. Now using this formula, okay, what is the electric field at this point? So if I take this line out here, okay, this line is taken as a point C. If I look at this line in this direction, okay, it will appear as a point, no, going in z axis, and I have to find out the electric field out here. Okay, so if I apply, okay, the x component of electric field, the x component of electric field would be in this direction, isn't it? See the line, the x component of electric field will be k lambda by this distance in this direction. So electric field in this direction is equals to k lambda by r into sine theta from phi a to phi b. Okay, now to note something out here, phi is nothing but this angle. Okay, if this was the point in space, phi is nothing but this angle. These angles are phi angle. Okay, okay, fair and fine. Now this was a plate, no, a plate carrying charge density lambda. I have to integrate this line from top to bottom, isn't it? So let's name this distance, instead of x, let's name this distance h, or hypotenuse. Okay, so k lambda by r would be transformed to k lambda by h. Okay, and I have to integrate this entire plate. So let's take this horizontal distance as r. Okay, and how do I integrate this line, or how do I integrate this plate? Convert all the vertical element and hypotenuse element in terms of r and theta or phi angles. Instead, I've done this before. Okay, whenever line integral comes up, the first intuition should be I have to convert all the vertical terms and the hypotenuse terms in terms of horizontal length and angle theta, or in terms of the fixed horizontal length. Out here, r is fixed, no? Doesn't matter wherever you are. Doesn't matter if you are at this point or at this point. The value of r would be fixed, no? So to convert all the vertical terms and hypotenuse terms in terms of r and this angle. Okay. So this angle is nothing but, or this length is nothing but x, where this thickness is dx, and let this angle be psi. Okay. One thing to note out here, phi was this angle. Okay. This angle was phi, whereas psi is nothing but this angle. Okay. That means phi was nothing but this angle. Okay. And psi is nothing but this angle. Understood? So what is the component of this electric field along this direction? Let this direction be Ex is equals to k lambda by h into sine theta from phi a to minus phi b. Okay, minus phi b into cos phi. Okay, if this angle is phi, this angle is also phi, and component of this electrical field in this direction is nothing but into cos phi. And why am I not using this Ey or y component of electric field? Because the paper is symmetric. Okay, the paper is symmetric. That means what? The y component of electric field. See, in this direction, the y component of electric field will be in this direction, isn't it? Sorry, in z direction towards yourself. Okay, the y component of electric field would be towards yourself. See, I've taken this line. Okay, this was my line. Okay, and this is my point. Okay, if I look at this, x component is in this direction. What is the y component? In this direction or this direction, isn't it? So this direction, when I rotate it, it will be towards yourself or away from yourself, isn't it? See, this direction, see, understood? So y component of electric field would be in this direction, and due to symmetry, okay, the y component of electric field would get cancelled. That's why I'm not calculating the y component of electric field. Fair and fine. Now see, x component of electric field is given by this formula. I have to convert one more term, lambda, out here. Lambda was what? Linear charge density. But out here in the question, what is given? Surface charge density. So what remains constant? The amount of charge in this elemental strip will always remain constant, no? So dq is the amount of charge in the elemental strip, which is equals to lambda into thickness of the strip. Let the thickness of the strip be b. Okay, into lambda into b, which is equals to surface charge density into area of the strip. Area of the strip is nothing but b into dx. So b into dx. If I take these two terms, lambda b is equals to sigma b dx. So out here b and b would get cut. Lambda is equals to sigma dx. So if I substitute this lambda out here, what do I get? X component of electric field is equals to k lambda is substituted by sigma dx by h into sine theta from phi a to minus phi b into cos phi, isn't it? Fair and fine. Now how do I integrate this? I have to convert all the vertical terms. The vertical terms out here are dx, dx, and the hypotenuse terms out here are nothing but h. So if I substitute right now, substitution, spelling of substitution might be wrong, subst, tution. Okay, don't focus on that. Spelling is not important in physics. Okay, out here, the first substitution I should do is, how do I convert dx? In order to convert dx, first I might convert x. So out here, tan psi or tan psi is nothing but perpendicular by base, or x by r, x by r, or out here x is equals to r tan psi. Now dx by d theta or dx by d psi is nothing but r sec square psi. The differentiation of tan psi is nothing but sec square psi. Okay, or dx should be equals to, or dx is equals to r sec square psi d psi, isn't it? And the third substitution should be, I must also substitute this hypotenuse term in terms of r and psi, no? So okay, cos psi is equals to r by h. Cos psi is equals to r by h, or h is equals to r by cos psi or r sec psi. Okay, now if I take these three substitution out here, what do I get? Ex is equals to k sigma into dx. Dx is nothing but r sec square psi into d psi. This is nothing but dx divided by h. H is nothing but r into sec psi into sine theta from phi a to minus phi b into cos phi, isn't it? So these are the term or the component of electric field in this direction. Okay, now if you carefully observe this, cos phi and sec square phi will cancel to form sec phi, and this sec phi and this sec phi would get cancelled. So out here all the trigonometric terms are getting cancelled. Out here r and r is also getting cancelled. Okay, so if I cancel out all these terms, what will remain is x component of electric field is equals to k lambda into sine theta from phi a to minus phi b into d psi. Okay, and I have to integrate this d psi from the upper limit to the lower limit. Okay, from this angle to minus of this angle. So let this angle or let the extreme angle be psi a, and let this extreme angle be minus of psi b, minus of psi b. So from psi a to minus of psi b, and when I integrate this, x component of electric field is nothing but k sigma sine theta from phi a to minus of phi b psi to psi, or psi a to minus of psi b. Okay, I have rewritten or written the order little bit wrong. From minus of psi b to psi a. So that means we are starting from the bottom, we are going to top. Lower limit, upper limit. Minus psi b lower limit plus psi a upper limit. Okay. Now there is a special case, okay, which will be related to Gauss law in this formula. The special case is what happens when the size of this plate becomes infinity, okay, or an infinite square plate or an infinite plate. Okay, so what happens when this plate becomes infinity? This phi a, okay, phi a and phi b also becomes infinity. For this plate, phi a will become infinity and phi b will also become infinity. So sine of 90, okay, minus of sine of minus 90, okay, for infinity. So special case, okay, shell case for infinite wire, for infinite plate, not infinite wire, infinite plate. For infinite plate, what happens? Psi a becomes 90, okay, psi b becomes minus 90. Then what? This becomes also 90 and psi b also becomes minus 90. Okay, in this side also it will make a 90-degree angle. This term, this side also becomes infinity, and if you look top to bottom, this side also becomes 90. For this plate to go towards infinity and towards infinity at the bottom, this psi a and psi b also will become 90 and minus 90. No, understood? Now see out here, if you check the formula, Ex is equals to k sigma sine theta from psi a to minus of psi b into phi to phi a to minus of phi b. So when psi a and psi b becomes 90, what happens to this sine theta? Sine 90 minus of sine minus 90, and this entire terms becomes 2, isn't it? And out here this becomes phi a becomes 90 and phi b also becomes 90. And how do I write 90 in radians? 90 is nothing but pi by 2. So phi a becomes plus pi by 2, phi b becomes minus pi by 2. So out here minus pi by 2, minus of minus pi by 2 is nothing but pi by 2 plus pi by 2, which is nothing but 2 into pi by 2. 2 into pi by 2 is nothing but pi. Okay, see out here. Pi by 2 minus of minus pi by 2 is nothing but pi, no? 2 into pi by 2. That is only the entire thing I've written out here. For infinity, this becomes positive pi by 2, this becomes negative pi by 2. Okay. So electric field due to a infinite charge carrying plate becomes how much? 2k sigma into pi. Okay. 2k sigma into pi. Understood? Now in the next slide, I'll explain how these are related, or how this Coulomb's law and how the Gauss law are related to each other. Understood? So now we are going to talk about a little bit of similarity between Gauss law and Coulomb's law. Okay. So most of you have heard about Coulomb's law. Is the first thing that you learned in electrostatics. Coulomb's law on the left and Gauss law on the right. What does Coulomb's law say? Force is equals to, or electric field is nothing but force on one unit of charge. Okay, kq by r square. But Gauss law says that electric flux is equals to E into A is equals to Q inside by epsilon naught. Now, if I apply this Coulomb's law for point charge, so there is a plus Q charge, there is a plus Q charge. Okay, I have to find out the electric field at point R, where R is R distance from the charge, where R is R distance from the charge. Okay, in Coulomb's law, we simply find out electric field is equals to kq by r square. In Gauss law, what do? We first create a Gaussian sphere, isn't it? Gaussian sphere. And electric field due to this Gaussian sphere. So electric field into area of this enclosed Gaussian sphere into 4 pi r square is equals to charge inside this Gaussian sphere, q by epsilon naught. Now check out here. Is this formula and this formula the same thing? Of course it's the same thing. See, if you check out here, k is nothing but 1 by 4 pi epsilon naught, isn't it? So this formula and this formula are the same thing. Similarly, due to a line charge, okay, suppose there is a line charge, okay, the electric field at point R, or the linear charge density, is given by lambda. The electric field at point E, or Ex is given by how much? K lambda by R into sine theta phi a to minus of phi b. So phi a is out here, this angle is phi a, and this angle is minus phi b. Of course, there exists a y component of this electric field, but right now I'm trying to show you the similarity between Gauss law. Okay. So what happens when this line is, or what happens when this wire is made infinity? Phi a becomes 90 and phi b also becomes 90. So this formula becomes Ex is equals to 2k lambda by r at phi a is equals to 90 and phi b is equals to minus 90. Okay, that means for infinite wire, or infinite wire. I don't know what happened for infinite wire, isn't it? Now similar kind of thing I can do out here. See, for a infinite wire, okay, carrying charge density lambda, how did you find out the electric field out here? First you created a Gaussian cylinder, isn't it? Gaussian cylinder was created, and electric field at point R, electric field in point R into total area of this Gaussian cylinder is nothing but 2 pi r into h, where h is the height of the cylinder, is equals to q inside. What is the charge inside this Gaussian cylinder? Charge density into h, or lambda into h by epsilon naught. Now if you see this formula and this formula are the same thing. That means the Coulomb's law we derive for infinite wire is same as this Gauss law. Understood? The Coulomb's law we derive for infinitely long wire in X component is same as the Gauss law you all did in your classes. Understood? The third portion would be a parallel plate. Okay. Similarly, what was the electric field due to a flat plate? Okay, on X direction, kept at distance r. It is nothing but our electric field in this direction is nothing but how much? K sigma into sine theta, okay, minus, oh sorry, phi a to minus phi b into d psi from psi a to minus psi b, isn't it? And if I integrate this for infinite plate, okay, carrying surface charge density sigma, what will happen? Ex, or Ex is nothing but k lambda, this will become 2 and this will become 2 into pi by 2. I've just derived this much before. Okay, so this will be the value for infinite plate kept at distance r, isn't it? Now if I use the same thing using Gauss law, see, okay, and to find out the electric field due to an infinite plate, and that infinite plate has charge density sigma. How do we do it? We make a Gaussian surface, isn't it? The Gaussian surface will be somewhat like this. This is the Gaussian surface, isn't it? This is A, this is A. So the electric field, how do we do it? Electric field in x direction, or Ex into area. This area plus this area is nothing but 2 into area is equals to q in. What is charge inside this Gaussian surface? Is nothing but this much charge, isn't it? Which is equals to sigma into A, or charge inside by epsilon, or Ex is equals to sigma by 2 epsilon naught. Now see, is this formula and this formula the same thing? Yes, of course. K is nothing but 1 by 4 pi epsilon naught. Okay, 2 pi and 4 pi will get cancelled. It will become sigma by 2 epsilon naught. So this formula and this formula are the same. So what I want to say out here is Coulomb's law is nothing but a fancy form of Gauss law. Okay, or Gauss law is nothing but a fancy form of Coulomb's law. Both are interrelated. They're nothing different. Understood? Gauss law just says a simplified form of finding out the electric field. Okay, or a Gauss law just helps us to find out the electric field in a simplified manner, much more simplified manner. Instead of integrating the entire component, this component, that component, we can simply find out electric field due to a line charge. Okay, but there's a limitation of Gauss law. Okay, suppose you want to find out for finite length of wire. Okay, the Gaussian surface will be very complicated. Okay, for flat plane of wire, the Gaussian surface will be very complicated. So Gauss law has its limitation. Okay, for finite length of wire, you can use Coulomb's law. For finite length of sheet, you have to use Coulomb's law. For infinite kind of lengths, you can use Gauss law. Okay, it's much simpler and it's much easier. Now we'll do question number 3.20. So in this question, what is there is there are two charges out here, positive charge and a negative charge. And we have to find out the flux through this disk kept at the center. Okay, what is flux? Flux is nothing but dot product of field and area. So out here electric flux is nothing but electric field into area vector into cos theta. But theta is the angle between area vector and electric field vector, isn't it? Now what I'll do? Problem is, how do I integrate the flux to this entire disk? See, whenever you hear disk is nothing but an integration of ring from 0 to R, isn't it? Up till now, you might have got the idea that integration of ring from 0 to R is nothing but disk. Okay, integration of a shell is nothing but a solid sphere. So out here, if I take this elemental ring, okay, of length x and thickness dx, I have to find out the electric field out here. Understood? If I find out the electric field out here and the flux in this ring, okay, what will happen? And if I integrate that ring from 0 to R, I'll get the flux through this disk. Understood my approach? Okay. So I need to find out the field through this ring. After finding out the field, I'll find out the area. After the area, I'll find out value of cos theta. Okay. So out here, electric field at every point in this ring would be in this direction. E positive Q, which is nothing but kq by h square, where h is the distance between the ring and the positive charge. Similarly to this negative charge, the electric field will in this direction, isn't it? E due to negative charge is equals to kq by h square, where h is the distance between the ring and the negative charge. Okay. Now I have to find out the component of this two electric field along the x direction. Okay, why? See, flux is nothing but electric field into area vector into cos theta, no? So if you look out here, the area vector of this disk, the area vector of this disk will always be in this direction. Okay, the area vector of this disk will always be in this direction. Understood? So if I just do E cos theta means component of all the electric field along this direction. Okay, so I have to take component of all the electric field along this direction. See, luckily for us, this is just a sheer coincidence. Luckily for us, there is a symmetry between positive charges and negative charges. That means the vertical component of electric field will get cancelled. Okay. All I am saying is, even if the vertical component of electric field do not get cancelled, take the component of electric field in this axis and electric field in this axis. That means my electric field or component of electric field should always be along the area vector, isn't it? This much is understood. Now see, if I make this angle theta out here, what is this angle? This angle is also theta. Why? Parallel lines. If this angle is theta, by symmetry, this angle is also theta. Parallel lines and symmetry. Okay. So total electric field is equals to kq by h square cos theta into 2 kq by h square cos theta into 2. That means I'm adding this in this direction, this in this direction. It will become 2 kq by h square cos theta. Now to integrate this electric field, okay, from 0 to 1, no, this electric field was for this much ring only, isn't it? And I have to find out the flux in this ring. So what is the flux in this ring? Flux in the ring is nothing but electric field in the ring, which is 2kq by h square cos theta into what is the area of this ring? The area of this ring is nothing but 2 pi r into dr. So area of the ring is nothing but 2 pi r into dr. Okay. Now there are different variables out here. Acha, 2 pi, not 2 pi r dr, 2 pi x dx. Because out here My radius of the elemental ring is taken as x, no? Understood? Now what I'll do is, all of you remember that straight line or electric field into a straight current carrying wire. Okay, there was a positive charge of its length. You have to find out the electric field out there. People remember that problem. What did we do out there? We converted all the vertical terms and the hypotenuse terms in terms of r or horizontal terms and angle. No, similar kind of approach we'll do out here. Okay, we'll convert all the vertical terms and hypotenuse terms in terms of L and theta. Why? See, because as I'm going down or as I'm decreasing the value of theta, what will happen? X will change, age will change. Okay, so in order to take in factor of the multiple variables, we'll convert everything into single or one or two terms. Okay, what will remain constant? L will remain constant. So I'll convert everything in terms of L and theta. And then I'll integrate from theta is equals to 0 to theta is equals to this value. Understood? That is my main approach out to deal with all these variables. So substitution. Substitution. The first substitution we have to do is how much? We have to convert this x, isn't it? So can I say tan theta is equals to x by L? Tan theta is equals to x by L, or x is equals to L tan theta. L tan theta. This is my first substitution. The second substitution, see, if I substituted x in terms of theta, I have to substitute dx also, no? So dx is equals to, or if I differentiate this with respect to theta, I'll get dx by d theta is equals to L integration of, differentiation of tan theta is nothing but sec square theta, or dx is equals to L sec square theta into d theta. Okay, so I got the second part of substitution. So up till now I have substituted x and dx. Okay, now what I have to substitute is this h. This h will also vary, as I go from up to down or down to up. So to substitute h, I can say cos theta. Cos theta is equals to L by h, or base by hypotenuse. L by h, or h is equals to L by cos theta. So if I substitute these three terms, x is equals to L tan theta, dx is equals to L sec square theta d theta, and h is equals to L cos theta out here, what do I get? Flux through the ring is equals to, I'll just solve it out here. Okay? Flux through the ring is equals to 2kq by h square. H square is nothing but L square by cos square theta, or L square into sec square theta. L square into sec square theta, isn't it? Into cos theta. Out there, this cos theta. Into 2 pi. Into 2 pi. The value of x is nothing but, the value of x is L tan theta. X is equals to L tan theta. L tan theta. And the value of dx is nothing but L sec square theta d theta. L sec square theta d theta. This is the value of dx. Dx out here. Now we'll simplify this one, or simplify this thing. Okay. How do I simplify? See, sec square theta and sec square theta will get cut. Then I'll find L into L will become L square. Okay. So let's erase as I'm making the progress. Okay. L will get cut, L will get cut, and sec square theta. Okay. Let me write this d theta closer so I do not get confused out here. Okay. I just wrote this d theta closer out here. Now cos theta and tan theta. Cos theta is nothing but, see, tan theta is nothing but sin theta by cos theta. So out here this cos theta and this cos theta would get cancelled. So cos theta and tan theta gets cancelled to become sin theta. Okay. So let me do that one. Let's write sine theta closer outer. I'll write sine theta closer outer. Sine theta. Okay. And I'll just bring this 2 pi d theta closer outer. 2 pi d theta. 2 pi d theta. Okay. Fair and fine. Now what is the flux due to ring? Flux due to ring has this value. 4 pi, see, 2 and 2 becomes 4. This 2 becomes 4. 4 pi k q into sine theta d theta. Sine theta dot d theta. Now I have to integrate this sine theta d theta from theta is equals to 0 to theta is equals to this value. Okay. So what is the integration of sine theta d theta? The integration of sine theta d theta is nothing but cos theta or minus of cos theta. Okay. So flux due to disk is nothing but integration of ring from theta is equals to 0 to theta is equals to this extreme value. Okay. So it becomes nothing but 4 pi k q into the value of sine theta d theta is nothing but cos theta. I want to integrate from theta is equals to 0 to theta is equals to this value or this line. Okay, this line, this value of theta. Now what is the this value of theta? See, or let's say this is phi. Can I say phi or cos phi? Out here, let me say cos phi is equals to how much? Base by hypotenuse. What is the value of base? L. What is the value of hypotenuse? Under root of L square plus R square, isn't it? This hypotenuse become under root of L square plus R square. No? So from this equation, can I say theta is equals to cos inverse L divided by under root of L square plus R square. Okay. Now if I integrate this value or if I integrate this value from 0 to how much? 0 to 5. I'll get nothing but flux due to or from the disk to the disk is equals to 4 pi k q into let me take this minus outside. Okay, into cos of phi. Cos of phi is nothing but L by under root of L square plus R square minus cos of 0, or cos of 0 is nothing but 1. So we get this value, isn't it? Now if I multiply this minus inside the bracket, what will happen? Flux is equals to, or flux to the disk is equals to 4 pi kq, 4 pi kq into 1 minus L divided by under root of L square plus R square, isn't it? Okay, so this will be our answer. Now in some books it is written Q by epsilon naught C. K out here is nothing but 1 by 4 pi epsilon naught, no? So if K is 1 by 4 pi epsilon naught, you can directly write Q by epsilon naught out here, no? 4 pi and 1 by 4 pi would get cancelled, isn't it? So these are all the same things written in divide. Let not get confused after. Understood? Acha, to solve this question, you need the idea of Gauss law. Okay. So Gauss law is nothing but electric flux is equals to dot product of electric field and area, which is equals to charge inside by epsilon naught. So most of you have already learned this inside class, isn't it? What I'm trying to show you out here is what happens if there is a sphere. Okay, the volumetric charge density of this sphere is given by rho. That means this is an insulating sphere, but all the charges are distributed inside the volume uniformly. Okay, this is the center of the sphere. What happens if I want to find out the electric field out here at point 1? The electric field at point 1, let this radius be r1, is nothing but electric field at point 1 into area. I'm applying Gauss law out here, or these two terms of Gauss law. Electric field into surface area of the shell is equals to 4 pi r1 square is equals to charge inside. Charge inside is nothing but volumetric charge density into volume. So rho into 4 by 3 pi r1 cube divided by epsilon naught. So electric field at point 1 would be rho r by 3 epsilon naught. What is the direction of electric field? The direction of electric field will be along the direction of radius vector. So it will be along this direction, isn't it? Along the direction of radius vector E1. So if this is R1 vector, electric field vector would be this one. So if I want to refine my formula, R vector and electric field vector. Fair and fine. Now what happens if I want to find out the electric field at point 2? Point 2 is inside the sphere. What will happen? First I have to draw a Gaussian sphere. Okay. I have to apply the same formula. Electric field at point 2 is equals to surface area of this Gaussian sphere, isn't it? Because I want to find out the electric field out here. So electric field of this Gaussian sphere is nothing but 4 pi r2 at point 2. This is nothing but r2. Okay, is equals to 4 pi r2 square is equals to rho into 4 by 3 pi r2 cube. That means charge density into volume of this much sphere only. Why? Because electric field out here would be due to charge inside this sphere, no? This remaining part of the charges won't be taking any part on this electric field, isn't it? Divided by 3 epsilon naught. Sorry, divided by epsilon naught. So electric field at point 2 would also be rho r2 by 3 epsilon naught. Okay. So from this diagram, what I've concluded is electric field at any point inside the sphere, okay, would be how much? Electric field at any point inside would be rho into r vector. Radius vector is nothing but the radius from center to that point divided by 3 epsilon naught. And the direction of r vector would be equals to the direction of electric field vector, isn't it? So this formula you have to apply in this question. Understood? In this question, what happens is there is a sphere, okay, of uniform volumetric charge density. That means the charges are situated throughout the volume. Okay, it is a insulating sphere. Fair and fine. Now I have cut this sphere from this side. Okay, the radius of the sphere is given as r, and the distance from where I have cut the sphere into two halves is nothing but r naught. This is given as r naught. I have to find out the electric flux through this surface area. So whenever you cut a sphere from this side, okay, if you just rotate it, this would not be a circle, no? This would be a circle. If you cut a sphere, if you cut a sphere and throw it out, if you look like this, what will be there? A circle will be visible out here, isn't it? And we have to find out the electric flux through this circle or through this circle. So let me erase this one, okay? And we have to find out the electric field through this circle. Now see, if I draw this diagram, I have to find out the electric field due to this circle. So electric field at any point in this circle would be, see, suppose I take point 1. Electric field at any point in this circle would be given by this formula. Rho is nothing but the charge density into r. R is nothing but the radius vector from the center of the circle divided by 3 epsilon naught, isn't it? Now to find out the circle or to find out the flux through this entire disk, what do you take? You take an elemental ring of radius x, okay, and thickness dx, isn't it? And if I integrate this ring from 0 to r, I'll get this entire surface area. And first I have to find out the flux through this ring. So flux through this ring is nothing but flux or electric field through this ring is nothing but rho r by 3 epsilon naught, isn't it? See, what is the angle between electric field vector and area vector? So doesn't matter where our electric field vector is. I always have to take the component of electric field in this direction. Why? Because area vector is also in this direction. No? So component of electric field in this direction or along the direction of area vector. So I have to take the component of electric field along this direction. Let this angle be theta. Let this angle be theta. Parallel lines. Okay. So out here, flux to the elemental ring is nothing but electric field rho r by 3 epsilon naught into area of the ring. Area of the ring is 2 pi x into dx. Okay, into cos theta. Cos theta is nothing but this distance. Okay, but this distance is nothing but r naught that was given in the question. See, r naught is given in the question, and this distance will remain constant. The horizontal distance will remain constant and not. Okay, so cos theta is nothing out here but cos theta is nothing but r naught or base by hypotenuse. Hypotenuse is nothing but, let's say, x by or under root of x square plus r naught square. But instead of writing under root of x square plus r naught square, I'll just write h. Okay, so rho r by 3 epsilon naught 2 pi x dx into cos theta. Cos theta. Understood? Now I have to integrate this from theta is equals to 0 to theta is equals to this value. So in order to integrate it, I must convert all my perpendicular terms and hypotenuse terms in terms of this r naught and theta. So let's take the substitution. Substitution is what? The first substitution should be how much? I have to substitute. Is there any x out here? Yeah, x is out there. I have to substitute x. So tan theta is equals to x by r naught. Tan theta is equals to x by r naught, or x is equals to r naught tan theta. Similarly, dx by d theta is equals to r naught sec square theta. So dx is equals to r naught sec square theta into d theta. Achha. Out here, do you have to substitute any other term? I don't think no. Okay. See, out here r is nothing but the value of h. No, this r out here is nothing but h, or distance from ring to the point or center of the circle. This r is nothing but h. I have written that out here. R is nothing but hypotenuse that I have written out here. Okay, and the third substitution is the value of h, where cos theta is equals to base r naught by h, or h is equals to r naught by cos theta or r naught sec theta. So if I substitute, the flux through the elemental ring would be volumetric charge density into what is the value of h, r naught sec theta by 3 epsilon naught into 2 pi x. What is the value of x? R naught tan theta. What is the value of dx? R naught sec square theta d theta. Sec square theta d theta. So, and cos theta is out here. Cos theta. So sec theta and cos theta will get cancelled. Okay. Let's cancel out all the terms that we can out here. Okay. So cos theta and sec theta got cancelled. What more? See. Sec square theta is nothing but 1 by cos square theta. And this is nothing but sin theta by cos theta. So out here nothing will get cancelled, but our integration terms would be, and one more term. Let me simplify this r naught. R naught, R naught, and R naught becomes R naught cube. Okay, guys, eliminate R naught first. Okay, 2 pi. Let me write it closer. Are there any other term? Tan theta into sec square theta d theta. Okay. So let me write these terms. Tan theta closer tan theta sec square theta d theta. Let me write these terms closer. Okay. Sec square theta d theta. I have to integrate it from 0 to 5. But 5 is the extreme angle out there. Understood? Okay. Now I have to integrate this tan theta sec square theta into theta. So I can directly use substitution, no? Or the values are standard. Tan theta is equals to t. So dt by d theta. So dt should be equals to sec square theta into d theta. Okay. So out here I can substitute this tan theta sec square theta d theta into t dt. And integration of t dt is nothing but t square by 2, isn't it? Now if I substitute this t square by 2 back to tan theta, is nothing but flux through this ring is nothing but rho r naught cube into 2 pi by 3 epsilon naught into tan square theta by from the value of tan phi is equals to 0, initial angle phi is equals to 0, phi is equals to 0 to phi is equals to 5, but phi is the extreme angle out here. Okay, now these two and these two will get cancelled. Okay, this 2 and this 2 is getting cancelled. So what is the integration of tan square phi from this limit to this limit? For this limit, can I say tan phi is equals to perpendicular by base? What is the value of perpendicular? The value of perpendicular is nothing but, let's see, if this is r, this is r naught, the value of perpendicular would be nothing but hypotenuse square or r square minus r naught square. So tan phi is nothing but perpendicular by base. So out here tan phi is nothing but perpendicular. Perpendicular is nothing but under root of r square minus r naught square by base r naught. Okay. I have to find out the value of square of tan theta. So tan square theta, tan square phi, sorry, not theta, is equals to whole square whole square whole square whole square. It is nothing but r square minus r naught square divided by r naught square. So if I find out flux through the disk, okay, if I integrate this ring from 0, phi is equals to 0 to phi is equals to pi, I'll get the flux through the disk. So flux through the disk is nothing but rho r naught cube pi by 3 epsilon naught into tan square phi. Tan square phi is nothing but r square minus r naught square by r square, isn't it? This value minus tan of 0. Tan of 0 is nothing but 0. So this is our answer. Or flux through the disk or flux through this much area has this value. So what I did out here, I just took and I cut the disk. Okay, I took the electric field and I took the component of electric field along the area vector. Okay, so while finding out flux, always remember you have to take the component of electric field along the area vector, or you can also take the component of area vector along the electric field. Both will be equal, but we'll apply the formula according to your convenience. That's up to you. But remember to take the component of electric field along the area vector or the component of area vector along the electric field, whichever is convenient for you. Understood? Both will be same. Okay. Out here a silly mistake I made out here. It is r square minus r naught square divided by r naught square divided by r naught square. Okay. So it will be r naught square by r naught square minus 1. But you can do those things by yourself. Okay. See, in this question, okay, there are two straight wires. Two straight wires means the wires are in this direction. Okay, the wires are along the z-axis. That means along yourself and far away from yourself. And this wire is also yourself and far away from yourself. and the length of this wire are infinity. Infinity means they are very long wire. Okay, two long parallel wires. Whenever the term long is mentioned, that means the length of the wire is infinity. Okay, the distance between the threads are L. So distance between these two wires are L. Okay, the direction of this wire is along the Z direction or along yourself and far away from yourself. And these two wires runs parallel by distance L. The distance between the wire is L. Fair and fine. Find the maximum magnitude of electric field strength in the symmetry of this plane located between the threads. So what is the symmetry of this plane located between the threads? That means what the question is trying to say is that, see, if I draw a plane out here, okay, plane that goes from you to away from you, that means the infinite plane is also in this direction. The distance of this plane to this wire should be equal to the distance of this plane from this wire. So this is a plane situated at L by 2 distance, and this plane is called plane of symmetry. That means this plane is symmetric to both the wires. Okay. Now the question is asking, I have to find out the maximum electric field at this point in plane. To find out the maximum electric field at this point in plane. Okay. So the first thing is first. What is the electric field due to an infinite wire? Remember the formula. The electric field due to an infinite wire is equals to 2k lambda by r, where r is the perpendicular distance from the wire, isn't it? This was the formula. Okay, this is the formula you have to apply after. Problem is, these two are infinite wire, fair and fine. The electric field due to this wire, see, if both are of positive charges, both are of same charges, okay, and carries uniform charge density, the magnitude of charge density is also same in both the wires. The electric field of out here due to this wire would be in this direction, and the electric field out here due to this left wire would be in right direction. So the electric field at the center would cancel out each other, no? Okay, so the electric field would be zero out here. Understood? So even if you put R is equals to 0, by formula, electric field should come out to be infinity or very high number. Okay, sorry, not R is equals to R, should be equals to L by 2. Okay, so the formula would come out to be very high number. Okay, but due to vector summation of the electric field would get cancelled, isn't it? Now, as I increase the value of R, what would happen? This denominator would increase, okay, and the electric field or the magnitude of electric field would come down. Understood the problem that I'm facing out here? At the center, the magnitude of electric field is very high, but the direction of electric field are opposite to each other, so they'll cancel out each other. As I go upward, okay, the electric field will get added, but as I'm increasing the R, okay, the magnitude of electric field itself is getting reduced. So somewhere between this point and infinity, there exists a sweet spot where the magnitude of electric field is maximum. Okay, so let that sweet spot be X. Understood? What is the electric field at this point X due to this infinite wire? It would be 2k lambda by this length, where this length is nothing but L by 2 whole square plus X square under root of L by 2 whole square. Let's name this, instead of writing L by 2 and this whole thing, let's name this hypotenuse. Okay, hypotenuse is nothing but base square plus perpendicular square. Similarly, the electric field due to this right wire would be in this direction, isn't it? It would be 2k lambda by hypotenuse. Understood? And total electric field, see, due to the symmetry of this wire, the horizontal component of electric field would get cancelled. The only electric field would remain is the vertical component of electric field. So let this angle be theta. Let this angle be theta. If this angle is theta, this angle is also theta. This is 90 degree and this is 90 minus theta. So if this angle is theta, this angle is also theta. So total electric field, E total, should be how much? Let's see, 2k lambda by r into cos theta. Okay, the vertical component of electric field, and you have to add this also, cos theta, 2 pi k lambda by h into cos theta. Out here I made a mistake, instead of r write h into 2. Okay, what I've done out here is I've taken the vertical component of these two electric field, 2 into 2k lambda by h into cos theta, 2k lambda by h into cos theta. Okay, that is the total electric field in the vertical direction. Understood this much? Now let me just simplify. E total is equals to 4k lambda by h into cos theta. Okay, now somewhere, acha, if I plot this h, or let me write this h in terms of L by 2 and x. Okay, so h is nothing but under root of h L by 2 square. L by 2 whole square is nothing but L square by 4 plus x square. Okay, and cos theta. Cos theta is nothing but base by perpendicular, base by hypotenuse. So cos theta is nothing but x divided by under root of L square by 4 plus x square, isn't it? I could do this in terms of theta also. If I made the entire calculation in terms of theta, as I did in the wire, as I did in for circular disc, even that portion is correct. Okay, but right now let's say an alternative method of algebraic integration. Okay, or out here you do not have to integrate, you have to differentiate out here. Okay, see, I have to find out the maximum electric field, no? So if I draw a function of electric field, if I draw a function of electric field versus x, that means at x equals to 0 will have 0 electric field, at x equals to infinity also will have 0 electric field. So somewhere in between you would have maximum electric field, and at maximum electric field what happens? dE by dx is equals to 0. That's why I've converted everything, or I've converted this theta also in terms of x and algebraic terms. But cos theta is equals to x by h. Understood? So total electric field, E total, should be equals to 4k lambda x by L square by 4 plus x square. Okay, now to differentiate for maximum electric field, dE by dx is equals to 0. So I have to differentiate this entire term and make it equals to 0. So how do I differentiate? D of electric total of 4k lambda are constant, I'll take it outside. D of x into L square by 4 plus x square, okay, to the power minus 1, to the power minus 1 by dx. By dx should be equals to 0. Okay, and this is nothing but differentiation by chain rule. Okay, chain rule of differentiation. Out here, what will we do? Take the first term, differentiate the L square by second term, plus x square to the power minus 2 into minus 1, and then take the second term also. Okay, now after that what do we do? We take the second term, plus L square by 4 plus x square to the power minus 1, and differentiate the first term. The differentiation of x is nothing but 1 only, should be equals to 0. Now when I solve this equation, I'll get the relation between x and L. And if I put the value of x, okay, out there or out here, I'll get the total or maximum strength of electric field. Okay, find the maximum magnitude of electric field in the symmetry of plane located between the threads. So let me solve this equation. Or if I solve this equation, a square by 4 plus x square to the power minus 1 is equals to, I took this entire term to the right hand side. See out here minus, no? So if I take this entire term to the right hand side, it would become x into a square by 4 plus x square minus 2 into 2x. Okay, this 2x and this x would become 2x square. 2x square. Okay, so out here this minus 1 and minus 2. See, if I bring this entire term to the left, okay, this term to the power minus 1 divided by this same term to the power minus 2. So minus 2 will go up and it will become minus 1 plus 2. So this would become minus 1 plus 2 is nothing but plus 1, and this entire term went to the left hand side. Okay, now let me open up the bracket. 2x, can I take this x square to the right hand side? So it will become out here x square is equals to L by 4. Okay, or if I simplify this, x is equals to L by 2. Okay, under root of x square is equals to under root of L square by 4. So out here let me write this simply. X square is equals to L square by 4. Okay, so x is equals to L by 2. So at distance L by 2, at x equals to L by 2, we get the maximum value of electric field. Understood? So putting the value of E maximum at L by 2, x equals to L by 2 would get the maximum value of electric field. E max is equals to 4 k lambda into L by 2 divided by L square by 4 plus L by 2 whole square, or L square by 4 plus L square by 4 is nothing but L square by 2. Okay, this entire thing would become L square by 2. L square by 2. Okay, these two and these two would get cut. I'm cancelling out L and L square. So E max is equals to 4k lambda by L, where L is the distance between the two wires. Okay, so in this question we haven't converted every this term or every vertical term and hypotenuse term in terms of length and theta. We didn't do that approach because out here we have to apply differentiation, no? And we have to differentiate the electric field with respect to x, and for maximum d by dx is equals to 0. Okay,